Hello, everyone. This is the fourth episode of the TwInsider short series. Today we have here with us the German demo. From E.ON we have Felix Dorsemagen, who is leading the German demo, and also Ellen Janneke, who is representing MValue, and they will give us the presentation, but not only a presentation, but there is going to be a demo as well. So without further ado, Felix, I would give you the floor, and then you can move ahead to.
Thank you very much. I'm going to share my screen. Okay, I hope everybody can see it.
Yeah, looks perfect.
Good. Hi, everybody. Hello and welcome from my side as well. As Laurent said, my name is Felix Dorsemagen. I'm working for E.ON One as a project coordinator for the German pilot within the TwinEU project. And I will present this demo together with my colleague Ellen, who is of MValue and who will give a short demo of our intelligent grid platform, IGP. And yeah, the topic of the TwinEU German pilot is about digital twins for grid monitoring, flexibility, and grid connection. Just to give you an overview, what is the project in general about? As you know, the TwinEU project in general is about utilizing and enabling the digital twin so that we can improve and optimize the energy system, and in our case, especially the grids. And as one of the 8 demos, the German demonstrator is, as many other grids as well, and as many other demonstrators as well, we are facing different challenges, of course, such as the growing renewables, more and more decentralized assets, but also new regulations. From the German perspective, just give you a small intro. There is especially important for our demo was the paragraph 14a and c of the ENVG, which is basically about enabling grid operators to control households, to control flexible grid assets if congestions are happening or are forecasted to happen. And so this helps them to deal with the congestions. But it also imposes new requirements on them in terms of monitoring, which is why the demo was also working on the monitoring part. I know this webinar is, I think the title of the webinar was about the TSO-DSO exchange specifically, but I'm gonna give an overview over the whole pilot, since basically monitoring and transparency in the grid is, of course, the foundation for everything that is happening between the TSO and the DSO. And especially on the low voltage grid, we need the ability to have transparency and coordinate and steer assets. And so this is why in the German pilot, we basically have 3, let's call it clusters in 8 use cases. The first cluster, which is the foundation I was talking about, is about grid monitoring, especially state estimation. We have basically 3 use cases in the German pilot here. And then we also have the topic of end-to-end flexibility, which is basically about dealing with flexibility through the whole process, using it for congestion management, and also talking about, as you know, the TSO-DSO exchange, which is necessary and which also needs to improved for all the necessary steps afterwards. And last but not least, we have the topic of hosting capacity map, which is of course a very pressing topic, since all DSOs throughout Europe have more and more connection requests. And this needs to be done, digitalized and automized. And this we have worked on during the last 2.5 years with all the partners you can see here. And I'm going to skip to the next one, which is about the grid monitoring part. So as you know, low voltage is especially tricky when it comes to visibility and transparency, since this is still not given everywhere. And especially with a smaller number of measurements, and then in the rest of the grids, this is still a challenge. And one part of the German pilot in the TwinEU project was basically about improving the grid monitoring. and especially Envelio and Vestnetz worked closely together here to improve this monitoring. There were several things included. We basically implemented or introduced a new and improved state estimation algorithm. It's all about visualization of the low voltage grid and congestion. So congestion management, of course, is also a big topic here. And the state estimation was improved by including more and more measurements, but also by including the ability to deal with topology changes. And the congestion management basically is important part for grid operators to, first of all, detect violations, of course, and then automatically trigger measures to keep the grid within the limits. This is the most important part also for the next steps, but there are also additional functionalities which have been developed as part of a pilot. For example, a field assistant for workers which are actually working in the field, and they help, or this mode or this functionality helps with virtual switching, live measurement access, and incident detection. And this is why grid monitoring is very important. And I will hand over to Ellen now for a short German demo so that you can see that what actually happened there. And the floor is yours, Ellen.
Thank you very much. All right, then I will share my screen as well. And you are seeing now the dashboard of the intelligent grid platform Felix was talking about, where we in general give the possibility to check on further or a few use cases. You can see here in those applications, and now jumping at first in the grid transparency, we can see here as an example grid. So this is our demo cluster at the moment, and I will lead you through the grid here. We can see here that the grid in general is colored by each grid. So a grid is defined here as everything under one trafo and transformator, and exactly we can see here the layers of the grid. So we see the grid participants, we see the primary substation, the switching station, etc. And can also see here with our map layer on how we want to visualize the grid. So we can also switch here between low voltage, medium voltage, and high voltage, of course. And for example, when I turn off the medium and high voltage, I can take a look at our low voltage grid and also show here the line capacity. So for example, here on loads or generators, I can switch between those layers. And for the grid planner, it's interesting to just like take a look at the grid state and differentiate between several layers here. So this like as a baseline actually of the platform. And then we can jump to the time series control center. So what is very relevant, of course, to be able to have like a state estimation of the grid live. It's of course relevant that we integrate the time series, so live grid measurements to be able to measure the grid every minute. And here, for example, I just like selected one station and we can jump into the grid time measurements here, for example, and see for now some voltage measures. I selected that we got measures every minute. I can see that here, also zoom more into the graph if I want to take a look at the measurements more in detail. And I can also switch, of course, between different stations, between different devices. For example, if there are also IMSIS measurements integrated, I can take a look at those. Or here, for example, the station measurements, and of course also switch between the kind of measurement and take a look at the measurements I want to see, and then also of course switch into the grid transparency again and take a look on where the asset is exactly. Also, if there are other measurements in that grid, I can see here and switch that measurement point out, and take a look at the grid in more detail and also analyze the measurements in more detail. So that also is a quick check about our time series control center. And here in the German pilot, we integrated several time series and live measurements with our partner Westnetz. So they can now really have a look on the measurements live in detail on each grid and on their households or loads in general, or also, of course, on stations. And this as a baseline for the grid monitoring, we jump now into our operation area. So here we see the online monitoring, the congestion management, where we will dive into deeper. And opening the online monitoring, I directly also get to that dashboard. So for our online monitoring, it's very relevant that we have a state estimation of each grid. We are able to measure every minute. And here we directly give an overview of if there are any violations, for example, in those measured grids and in those monitored grids. And if those grids in general are able to steer down. So if there's congestion, I'm able to handle this congestion, or if I just want to monitor the grid. I can see that in our grid status. So here we can switch the grids into monitored, for example. I can take a look here. Or if it's monitored, or if I want to control the grid, or if I don't want to monitor it at all. So I can switch the status here between my grids and also decide which grid I want to put in the online monitoring. So this is up to the DSO. And then I see here in my overview which of those grids has a violation at the moment and which of those grids are also controllable. Here we have now all grids controllable. So we see here that 4 of our grids are without limit violations and some are with limit violations. And this is something we can take a look here into more in detail. So I see here our 5 grids, and I can also see what are the criteria regarding our 14A paragraph. So this is like a German specific paragraph in which we have the legal requirement to be able to steer down grids if there's a congestion. And for this, we need some prerequisites, like the measurements are enough. So there are enough measurements in the grid so that we know we have a valid state estimation and are allowed to steer down. Or also one label is the accuracy, which states and compares if the measurements are similar to what the state estimation would expect. So if they are very close together, then the accuracy parameter is given, and this will also be displayed here as a check. And here now I see my grids, and I can also see if there are, for example, currently some active switching processes, so that I'm aware that something is ongoing in this grid at the moment, and can also give this in my analysis. And yes, also here on the right-hand side, you also see some further measures we take. So for example, what was the grid status in the last 24 hours, etc. Here also more details about our accuracy calculation and the maximal utilization of our assets, or the line and feeding transformators, for example. And yes, so here I see now that we have one congestion at the moment, which is here in that grid. So also when you see the display is kind of like loading again, it's that the state estimation did another calculation. So every minute it's loading and giving some new state estimation results. And we see here that we have a congestion in that grid. And in general, in an automatic process, it would now directly lead this grid into the congestion management app. But we are doing this now manually. So I will register that grid in congestion management. And we will take a look at the next application. So the congestion management is about giving an overview of what is actually currently as congested, which grids. And I can see here also how many controllable resources I have in my grids, which can be can be contacted and steered down. And now here we just saw like one control command was successful. So one of my controllable resources, or actually 8 of my controllable resources were steered down or contacted. And we see here now in that overview here that the grid we just registered is now active and a congestion resolution process was triggered. So we see here now this is happening in our grid. We see when the congestion started, and we also see which power delta we have for the regulator intervention in the grid. So here, quite a lot. And for now, it's in the 5-minute 5-minute time slot. And after the 5 minutes, we slowly check if the congestion was solved and if there's still congestion in the grid. If yes, we kind of we adapt a little bit on that normal state. And if we see it's still congested, then we steer down again. So it's not like an up and down, up and down. And if it's not congested, we would go slower again to the grid status, and the congestion process would be resolved. We can jump now here into that grid and look at the map. So we see here now in our grid, this is the grid that was registered, and we can turn off the measurements at the moment. So we can see the technical resources and the congested elements. So here I see, those are all my technical resources and the congested elements. I think it's now taking a look at the layer. Wait a second. It's here. I can also see here what means what. So I see here some of my technical resources are not steered down and some are controlled at the moment. And this is happening based on a discrimination-free algorithm that decides or calculates on which controllable resources need to be steered down. And this is happening within this algorithm discrimination-free. And so here I have that visualization of what is currently steered and what not. Again, the state estimation is working in the backend every minute and will calculate the new grid status. And I can also jump into my measurement analyzer here and see which measurements are actually measured and what the state estimation input would look like. So here we display what's actually going into the state estimation as an input value, and what was the calculated value and what was the actually measured value. So this can be also checked here and analyzed here in more detail to have a better view on how the measurements are actually going into the state estimation.
Great.
All right. Okay, then I think I'm a little bit, already too long in time, so I will hand over to Felix again.
Thanks, Anne.
Thank you very much.
That's great. No, it was really interesting and great to see what has been developed as part of the German pilot. So thanks for that demo. I'm going to switch to my view again, if I find it. There it is. Okay, I hope you see it again. So basically on the foundation of what Ellen just showed us about transparency and also congestion management, basically the next step is, of course, how to use that in the next step for also more use cases. And that leads us to the next part of our German pilot, where we develop basically an end-to-end process for flexibility management. And we develop the so-called envelope curve. as part of this program. This is a concept that basically describes boundaries for the flexible assets that we can control, also as part of what Alan just showed us. And the assets are then allowed to operate and adapt their generation or consumption without actually causing new congestions. That's the idea. And this envelope curve is basically developed and also created by the IGP together with the DSO, and then communicated to flexibility aggregators in the next step, and then again to the potential home energy management system, so that it is ensured that when you control flexible assets, that you don't cause new congestions in the grid. So it basically what you achieve here is a proactive instead of a reactive congestion management. And this concept was basically developed by improving the forecasting of substation feeders and distributing these boundaries that you then establish to the individual households where controllable assets are. And this, of course, helps as part of the congestion management and for the German DSOs for meeting the requirements of the 14A and C. So this is one part of the cluster B. The other part is basically what to do with this envelope curve. And here we basically did two use cases where the envelope curve was used. First of all, we used our partner EDG, E.ON Deutschland, which is our aggregator, and they used flexible assets in the grid to actually aggregate these and to perform basically two use cases. First of all, one was the self-optimization of households. So they want to, of course, save money by using their energy when it's cheapest. And the home energy management system then was basically self-optimizing our households while ensuring that the restrictions of the envelope curve were met. That's the first part, and what you can see here in the slides is basically the different consumer in the grid, which is basically restricted in their actions by meeting the envelope curve. And the other use case where we looked at a more sophisticated use case was basically aggregating households to achieve more power for future, for example, real dispatch mechanisms. So the aggregate power was used as a potential power to help TSOs as well, but also while ensuring that the envelope curve is met. And our challenge here was to find enough pilot consumers, households which are participating. So next step is, besides regulatory design, to find even more participants for the next test, basically. And based on that, what we did here, we basically also talked about the topic here, the TSO-DSO exchange of data, which of course needs to be improved to make the flexible assets also available for the TSO. And basically what we did here in our 7th use case is that we focused on two main topics. First of all, we installed and tested the TwinU connector, so the data space concept basically on servers at 3 of our partners. That was at our DSO Westnetz. It was installed at Amprion, which is our TSO in the pilot, and the aggregator. And basically in the first step, they tested this data space connectors, exchanged simple data to make sure that it's working and that it's functional basically for more sophisticated use cases. So that was the first test of the TwinU connector. And then in the second part of this use case, basically we developed a simulation in which a TSO is requesting aggregated flexibility, for example, for future redispatch mechanism. And the request and all of the communication is basically going through the data space and the data space connected. So it was simulated as a day ahead process where the TSO is first of all requesting power. The DSO is then, together with the IGP, as I said, forecasting and creating the envelope curve for the affected households in the area. In our case, that was that were two primary substations between Amprion and Westnetz. And then the aggregator in its role is aggregating all the flexible assets and basically offering the TSO aggregated power, and all the communication basically is going through the data space. And it was working. So our results basically is that the concept is sound. Data spaces are a viable foundation, but for now, it's not really ready for critical grid operations because of public internet infrastructure, because of OT security reasons, and so on. So there needs to be done more work here. And also there's, of course, the tension between this new concept and established platforms for example, for redispatch and so on. So we need a more governance here. This was about the flexibility usage. Last but not least, our third cluster was about hosting capacity. As all of you know, hosting capacity and connection requests are a big topic here. So we also developed some solutions here. Basically, we did two things. First of all, Envelio, besides its developments for grid monitoring, worked on a right now fully functional and operational hosting capacity map and functionality. There are basically several apps included. There is a transparency app where the IGP helps the DSO to see where capacity is existing. So it's a tool mainly for the DSO itself. And then there are several tools for project developers and outside entities. Basically, there's the online connection check, which is a near instant check of connection feasibility. We have an app for connection request processes. So it's an app which helps the DSO in automatizing and digitalizing the processes. And we have the grid connection navigator, which you can see here in the map, which is specifically for project developers to find suitable locations in the grid where they can install new, bigger installments. So it's fully functional, but unfortunately, due to data security reasons, we were not able to implement that on the Westnetz cluster. It is operational within external DSOs, but not as part of this project. And that's the reason why we also work together with our TwinEU partner ETRA on a pan-European scenario, which basically is there are several pan-European scenarios in the TwinEU project, and they are meant to show that digital twins can help the whole of the energy system in Europe by standardizing interfaces and data formats. And what we did here as part of the German pilot was basically ETRA developed this simple capacity map, as you can see here. And then through standardized data, we communicated this kind of data. It was, in our case, synthetic data. It was communicated through the data space again to ETRA. And then, as you can also see here, it was communicated and visualized on this map developed by ETRA. So here we showed that the technology of the database space is also ready for this use case. There are still some regulatory questions as always, but in principle, it is a suitable way. That was our last use case to come to an end. Basically, we are very proud of what we achieved. I don't want to go into the details again. I showed you what we basically developed as part of the pilot. Key lessons from our side are basically that you need to include digital twins in the formal operation processes. Otherwise, you will not be able to roll and scale them up. Data governance and data quality is always a big issue. So it's not the technology which is the biggest problem, but these two topics. And regarding the data space concept, we would say it's a very good concept, but it's, as I said, competing with existing proprietary solutions, and it's not really ready for critical OT infrastructure yet. So there still need to be done. And I want to thank you all for listening. And that's from my side. And as always, now or also later, we are happy to answer any questions. Thanks.
Thank you very much, Felix and Alan, for this presentation, and not just the presentation, but it was really nice to have a peek into this into the tool and see what it's capable of. So thank you very much once again for that. However, time is running out, but still, maybe we can have at least one question if there is from the audience. So if you have a question about the presentation, please just raise your hand and I can enable your microphone and camera. While we are waiting for that, I can tell you that after the session, as always, of course, the slides will be shared just as the video. And yeah.
As I said, we're happy to answer questions also afterwards when they come up later, maybe, but yeah.
Definitely. I don't really see any questions. So then maybe just one public announcement to make is that we are halfway in the TwinU short series. So we will continue after the summer break in September. And of course, you can follow it on the TwinU channels. And yeah, for now, thank you very much once again for both the audience and the presenters. And I wish you a nice rest of the day.
Thank you very much as well.
Thank you very much.
Bye.
Have a good day. Bye.
Bye-bye.